All right, so I have an AP problem, 2007, free response, Form B, question number 4, all right? And right away, you see that it gives you a graph of f prime. It gives you the graph of the derivative, all right? And it says f's a function on the interval -5 to 5, and it gives an initial condition, not of the derivative, but of the function. At f of 1, the initial condition is 3. So there's a 0.13 on the graph of f. The graph of f prime, the derivative consists of 2 semicircles and 2 line segments shown above. Does everybody see 2 semicircles? One here, and then 2 lines, right? Now, I suppose we can figure out formulas, but we also know that more than likely we won't want to do that, right? We know that the area of a circle is pi r squared, and we know the area of a triangle is 1/2 base times height. So going in, we got to be seeing that here, because the area under the curve, right, will get us where we probably want to go. So, it starts off for the region -5 to 5. Find all values of x at which f has a relative max. And it wants you to justify your answer. All right, I see 3 critical points when I read the graph between -5 and 5. So I don't include this point, even though it's 0. I see 3 critical points. -3, 1, and 4. Because it's a graph of f prime, I'm reading where does f prime equal 0? Well, that's those 3 points. All right, so I would start by labeling A, right? So here's the first thing I say. Well, f prime equals 0 at x equals -3, 1, and 4. Local max, do you guys agree? Occurs when, when f prime does what? F prime goes positive to negative. You guys agree? So where does it go positive, negative? I think it goes positive to negative here at -3, and I think it goes positive, negative at 4, which occurs at, which happens at x equals -3 and 4. What is 1? Min, guys. 1 is a min, because it goes negative, positive. That's a minimum. All right? So we have 2 local maxes, -3 and 4. All right, if I grab the scoring sheet here, that was worth 2 points. The 2 values and the justification. And I probably want to reference that this was the first derivative rule, by first derivative rule, okay? I'm going to not write it and being lazy.
So, Mr. Anderson, that 1 would technically be taken out of your answer, right, since it's a local min?
Yes, you notice, but I say I defined it up here. My answer is right here. So I would get full credit for this. I would get full credit for this, the 2 points. I identified the 3 critical points in the first line here, and then I defined local maxes happening there in the reason.
Okay, so what does the 1 have to do with anything then?
The 1 is just a okay. The 1 is one of the places where f prime is equal to 0. It has nothing to do with local maxes, but it's possible, I guess in all fairness what you're asking, the 1 has nothing to do with local maxes. The 1 is a local min. But,
okay.
Allie, usually we define where f prime is 0 before we jump off and define local maxes and mins. And 1 is a 0. That's all I was doing.
Okay.
All right? All right. We're going to minimize those 2 points, put that up here. So if this is homework, guys, you'd only have to earn 2 more points for the whole rest. You have to, and if you made a good, legitimate attempt at this and you accidentally had told me -4 and 2, I'd probably go through why it was wrong and still give you full credit. More often when I score AP problems, I'm looking to correct your thinking when I'm grading the homework, not grade them. Does that make sense? All right. So for letter B, for the interval -5 to 5, again, you notice it's open, guys. No equal signs, right? Open intervals. Okay? Open interval. For that open interval, find all values of x at which the graph has a point of inflection. Hey, now I'm interested in the shape of the curve. All right? Find all values of x at point of inflection, justify your answer. Guys, I am looking for B. I am looking when f prime prime changes sign. I am interested when f prime prime changes sign. So the first thing I might do is go, when is f prime prime equal 0? So I look at the graph, and I want to see places where f prime prime equals 0 or is undefined. All right? Does everybody see that f prime prime is 0 here, 0 here, and it's undefined here? Do you guys agree? So at x equals -4 and -1 and undefined at x equals 2. All right, so now that doesn't make a point of inflection, everybody. I can't stress this enough. A point of inflection occurs when there is a change in the sign of the second derivative. Now we have a graph of the first derivative. So now I want to look at the shape of the curve going into those sections. Does everybody see that it goes from increasing to decreasing? So the first derivative is 0 at -4, or the second derivative is 0 at -4, and it goes from positive to negative. Guess what? -4 is the point of inflection. Due to sign change of f prime prime, there are points of inflection at I'll get back into x equals -4. Then I look down here, guys, same situation. It goes negative to positive. You guys agree? -4, -1. And what about 2? Well, it's undefined there, but what does the sign of the second derivative do? Positive, negative. So guess what? It is a point of inflection. And that's it. So that's the answers, and that's 2 points too. So now, if you had no clue on the homework how to do C and D, you'd still get full credit. I would just want you to make some attempt at it. All right? So there's the answer to that. All right? And again, you notice all the rules come crashing back over and over and over, right? About sign changes, second derivative rule, first derivative rule. All right, the next one, letter C. Find all intervals on which the graph of f is concave up and also has positive slope. Explain your reasoning. All right, positive slope. And it's asking about the graph of f. You don't have the graph of f. Does everybody agree? Right now you have the graph of f prime. I think, personally, I don't want to deal with concavity first. Concave up means what? F prime prime is greater than 0. So let's keep that in mind. We want to know where f prime prime is greater than 0. That's concave up. All right, I'll put that in notes. And they want a positive slope. What does that mean? What does this mean? Positive slope, I think, means that f prime is greater than 0. Right? That's the positive slope. So the first thing I want to do is I'm going to look, where is f prime greater than 0? There's only 2 spots, 2 intervals. 1, 2, 4, right? And -5 to -3. So I would identify those regions first. -5 to -3, and I said 1 to 4. All right? So now my question, instead of going to, all right, instead of looking at intervals all the way, that positive slope thing has limited me to just being able to look at just 2 sections. I'll trace them in red. I can just look here. So the question is it concave up from -5 to -3 or some part of that? And where is it concave up in between, or is it concave up between 1 and 4? All right. Again, I see that I am now looking at the shape of this curve because I want to know what the second derivative is. Everybody, I think it's concave up right here and right there. And the question becomes, why did I pick those 2 spots, right? Derivative is positive. So my regions here are -5 to -4 and 1 to 2. And that'll be the 2 intervals. of the final answer. All right? So, a couple ways to write it. I would write it this way. Concave up when f prime prime is greater than 0. Positive slope, right, means when f prime is greater than 0 happens, and I would probably use interval notation. I noticed on the AP instructions I used happens at, and I would do it this way. I would do open intervals, right? You guys are used to my notation this way. I'll tell you the AP test did it this way. I was just looking at the answer. It intervaled it this way, right? Same thing. You guys agree? But you get credit for it, all right? And again, there's 2 points. So think about it. Every AP problem is 9 points. We've done 2, 2, and 2, so we're 6 points in. All right? We're 6 points in. And the hard part here, this is difficult, guys, without practice, and that's why we assign the AP. Reading curves is hard to do. This is not easy. And if I make it look easy, it's just because I'm old and I've done a lot of math. All right, so this takes a lot of practice. This is why we're going to do a lot of AP problems. Last one, find the absolute minimum value of x over the closed interval, -5 to 5. Explain your reasoning. Well, we found the maxes. Now it says find the, it didn't say where. You notice in number 1 it says find the x values. What's D say? It wants the minimum value. Now this is a hard problem. Yeah, we're going to have to go back. First of all, where does it occur? Where's the minimum occur? Nope. I think the minimum occurs at, 1. Yes. Shoot. Yes, I'm sorry. The minimum occurs at 1 because it goes negative to positive. I'm sorry. Yes. You guys are right. The minimum occurs at 1. So on D, we can make a pretty fast note. Occurs at x equals 1, right? Oh, maybe not. Absolute minimum value. We know there's a local min there. Occurs at 1 is a local min, right? So there's a possibility, but there's 2 more places we got to check. -5 and 5. Why do we have to check -5 and 5? Closed interval. Or, is a local min, must check endpoints. Alright? Not disagreeing that 1's a possibility, but we have to check the endpoints, which are x equals -5 and x equals 5. Now, it's an AP problem. I'll guarantee that's almost for sure one of the 2 endpoints. Alright? Because I almost slipped into the trap here. You guys got me so, I got confused at 2 there, and I was looking at the wrong thing for a second, and then I jumped on 1. That's my first note, but I have to do a whole bunch of work here. So the hard part now is you're given the curve, right, of f prime, and they don't want the x location. They actually want the absolute value. Guys, this is a fundamental theorem of calculus, all right? And I'm going to write it this way. Does everybody agree, if I call this up here, that I can write that f of x is equal to the integral of f prime of x, right, dx? And if I want the value of the location, right, I could start someplace, all right, and go to some x value, all right? Now, the question becomes, why am I starting at 1? Because we have a value of the function at 1, guys. And that does change this function. So we're going to write that equation again here, all right? This is the fundamental theorem of calculus, right? If I can do the integral of a portion, we can do that. So, do you want to check -5, 5 first? Because guess what? We know the value of 1. The local min is 3. Do you guys agree? The value of the local min at 1 is 3. They told us that. You want to do +5 or -5 first? +5 first. Let's check +5 and see if it's more or less than 3. Guys, to do that, to find f of 5, I'm going to have to start with my known condition, which is f of 1 plus the integral from 1 to 5 of f prime x dx. That is the fundamental theorem of calculus. If I do that math, I think this is 3, because f of 1 is 3. And everybody, what is this telling me to do? What is that telling me to do? Area under the curve from 1 to 5. So I'm going to figure out this triangle, which is 2 tall and 3 on the base. You guys agree? Because it's 1 to 4. And this triangle over here, which is 1 tall and 1 long, and that's negative, right? The top triangle is positive, the bottom triangle is negative. So I have 1/2 times 2 times 3 plus 1/2 times -1 times 1. I'll make it negative, one of them. So I get f of 5 here, and that's from is 3 plus 3 is 6, 6 minus 1/2. I get 5.5. All right, f of 5 is 5.5. Do you guys agree that's greater than 3? So right now, I've checked one endpoint, and I'd still say that the absolute minimum might be 1. It's definitely not 5. Do we agree? But the next thing I'm going to have to do at this point is I got to check the other endpoint, which happens at -5. And this equation gets harder, because I'm still going to have to start at f of 1 from my known. And my integral has to go from 1 to -5. Does anybody notice a problem right now with my integral I wrote in red? Yeah, my limits of integration are backwards. Does everybody agree? So I would switch. Here's what I would do personally. You either have to pretend that this is negative here and that this is positive down here, which I don't like doing because I always say above the curve. But we have our rule, right, that I can switch the limits of integration as long as I switch the sign in front. So I would switch it from 1 to -5 to -5 and 1 and just go from positive to negatives. All right? And again, it's area under the curve. Ugh. 2 circles. Ugh. All right. Everybody, do you see this as a radius of 1? That's a positive semicircle. All right? Does everybody see this as a radius of 2? That's a negative semicircle. So I'm going to write, and I'll go 75% so you can't 100% so you kind of see this. So I have 3 minus, and I'll put it in parentheses. So the positive semicircle is pi r squared over 2, pi 1 squared over 2, minus the -1 on bottom, pi 2 squared over 2. All right? Wow. I guess what? I do the math. I get 1/2 pi minus 2 pi. I think that's -3 pi over 2. Everybody, I'm going to stop right here. Because what do you notice right now about that value? It's positive. In fact, it's going to be more than. You guys agree this is more than 3 right now? Guess what? The endpoints weren't it. Remember I said at the very beginning that I thought the endpoints would be it? I guess not. So it is the middle one. So the absolute minimum value is what? The absolute minimum value, no. The absolute min value is 3. Boom, it didn't ask where. All right? And everybody. Again, I can't stress enough. It asked for the absolute minimum value. It is 3. And they gave it to you, but we had to check the endpoints. This is worth 3 points. It identifies x as a. It says that you identified x equals 1 as a candidate was worth a point. Just that sentence was a point. The other thing is that you check the endpoints. All right, which we did, both of them. And the third one was that you had the absolute minimum as 3. All right. Whoops. So everybody, keep practicing. The AP is coming.